Hello friends, welcome to Best Tutor. This is Rama Viswanatham. In today's video, we are going to learn about properties of multiplication of rational numbers. We are going to learn about properties like closure property, commutative property, associative property, existence of multiplicative identity and existence of multiplicative inverse. Let us get into the details of those. Let us learn about properties of multiplication of rational numbers. Properties of multiplication of rational numbers. The first property is closure property. What does closure property state? If at all I choose two rational numbers, then the product should be a rational number. Let us check it. Let me take it as minus 1 by 5. Now 2 by 7 into minus 1 by 5 is equal to, as we are already aware, the first step is to check if at all there are any common factors in the numerator and denominator. In this example, there are no common factors. So we move on to the next step. The next step is multiply the symbols. Here it is a positive sign, here it is a negative sign. Plus into minus is minus. Then the third step, multiply the numerators and put it as the numerator of the result. Multiply the denominators and that is going to be the denominator of the result. So final answer is going to be minus 2 by 35. So 2 by 7 into minus 1 by 5 is minus 2 by 35. Right. But is this a rational number? For a number to be a rational number or for a number to belong to the set of rational numbers, it should satisfy three conditions. What are those three conditions? The first one, it should be in the form of a fraction. Yes, minus 2 by 35 is in the form of a fraction. Second condition, both the numerator and denominator should be integers. Here minus 2 is the numerator, 35 is the denominator and both are integers. Second condition is satisfied. Third condition, the denominator should never be equal to 0. 35 is not equal to 0, therefore it is a rational number. So the set of rational numbers is closed under multiplication. The next property, commutative property. If at all we choose two rational numbers, I would like to find their product. The product remains very simple. There are no common factors. So ignore the first step. Second step, multiply the symbols. Plus into minus is minus. Third step, multiply the numerators separately and multiply the denominators. You get minus 2 by 15 as the product of 1 by 5 and minus 2 by 3. What if I change their order? That means minus 2 by 3 into 1 by 5. Do I get the same result? First step, there are no common factors. Second step, plus into minus is minus. Third step, 2 into 1 by 3 into 5. The answer is minus 2 by 15. If we observe, the answer remains the same. Whichever order you multiply those two rational numbers in, the answer remains the same. Therefore, for any two rational numbers a by b and c by d, then a by b into c by d is equal to c by d into a by b. This is commutative property. So till now we have gone through closure property and commutative property of multiplication of rational numbers. We move on to the third property, that is associative property. I choose three rational numbers. I have chosen three rational numbers, 1 by 2, 5 by 9 and 3 by 4. I would like to find out their product. 1 by 2 into 5 by 9 into 3 by 4. I group these two first. Then the product is, first of all, are there any common factors? Yes, 3 1s are, 3 3s are. That is the first step. Done. Second step, both are positive, both have the same symbol. 5 into 1 by 3 into 4. It becomes 1 by 2 into 5 by 12. Now again, do they have any common factors? I mean to say both the numerator and denominator. Do they have any common factors here? No. So move on to the next step. 1 into 5 by 2 into 12. And the answer is going to be 5 by 24. Right. This is one way. What if I change their order? If I change the grouping, I group 1 by 2 and 5 by 9. I find their product and I'll multiply the result with 3 by 4. Let me see if I am going to get the same answer or not. Are there any common factors here? 1, 9, 2, 5? No way. So we directly multiply 1 into 5 by 2 into 9 into 3 by 4. So you get 5 by 18 into 3 by 4 into 3 by 4. Now 3 and 18 have a common factor. 3 1s are 3, 3 6s are 18. So we are left over with 5 into 1 by 6 into 4, which is 5 by 24. So the answers are the same. That means the product remains unchanged whichever way you group those. So in other words, if at all there are 3 rational numbers, A by B, C by D and E by F are 3 rational numbers, then A by B into C by D into E by F, if I group C by D and E by F, remains the same as A by B into C by D grouped together into E by F. This is called as associative property of multiplication of rational numbers. Moving on to the next property, we have existence of multiplicative identity. So the next property is existence of multiplicative identity. What does it mean? I choose a rational number 2 by 5. I would like to multiply it with some rational number so that the answer remains the same, unchanged. The question 2 by 5 has to be the answer. What would be this rational number? Let us get back to integers. 3 into dash is equal to 3. Obviously this should be multiplied by 1. So here also we would multiply with 1. But is 1 a rational number? 1 can be written as 1 by 1. It is a fraction. Both the numerator and denominator are integers and denominator is not equal to 0. Therefore 2 by 5 into 1 is equal to 2 by 5 implies 1 is the multiplicative identity of rational numbers. So there does exist a multiplicative identity of rational numbers. The next property, existence of multiplicative inverse. Okay, if at all I have minus 3 by 7 as a rational number, yes, of course it is a rational number, I would like to multiply it with some other rational number. So the answer is our multiplicative identity. What would be this rational number is the question. Minus 3 by 7 into dash is equal to 1. So it should be minus 7 by 3. If we use the linear equations, let it be equal to x, then x will become 1 divided by minus 3 by 7, which is going to be 1 into minus 7 by 3 or minus 7 by 3. Using this procedure, we have got minus 3 by 7 into minus 7 by 3 is equal to 1. Therefore, there does exist a multiplicative inverse. Is it a rational number? Numerator, it is in the form of a fraction. Numerator and denominator are integers. Denominator is not equal to 0. So, for every non-zero rational number there does exist a multiplicative inverse. So we have learnt about all the properties of multiplication of rational numbers like closure, commutative, associative, existence of multiplicative identity and existence of multiplicative inverse. Thank you.